last time. Yeah, it was fun. There's no Zen today. Zen will not be joining us in the stream tonight. That is just fine. We're going to be going through the Project 5, which will teach us about motors, which I'm psyched about. Yeah, I don't know. I think my wife's doing a video call and I'm doing a bunch of stuff, so who knows about the frames, right? Yeah. How's the music level? Is the music level all right? A little loud, a little soft? What do we got? Audio seeming all right? Frames are for jerks. You're right. Can't hear any music. Well, you know. Then it's just me. We'll see how that is. Oh. It's too soft. That's the problem. There we go. All right, cool. All right, so I am excited about electronics this week. I started this Sparkfun thing like maybe, I don't know, 6 weeks ago, and been progressively getting more into it. I got a couple new projects that are on the way. I have my monitors all out of sorts. There's some new projects on the way, and I'm really psyched about them. Yeah, I'm so psyched. So let's see here. What do we have? Oh, I need to plug in my microscope. We'll do that in a second. So I've got these fun things. I got this fun thing. I got this in the mail. So this here is, I don't know if it's my next project, but it's definitely on the short list. And this is a PCB I ordered that is for a little macro keyboard. I have a friend who does a lot of, he just got a really nice content management job that he's psyched about. And he's like, bro, all I do all day is copy and paste. And so I really only need like 2 keys on the keyboard. So I'm going to make just a big copy button and a big paste button, or potentially like a few different clipboards that he could use. And so it would be 8 keys just with 2 sets of copy and paste, or 4 sets of copy paste. I don't know. But you solder in an Arduino Pro Micro, copy, cut, clear, paste. Yeah, that's good. An Arduino Pro Micro here, soldered in there. And undo would be good too, you're right. And solder some deals on here, and apparently, and you get a bunch of sample code and stuff too, so should be a fun time. I'm excited about it. So I actually got 2 of these. One I'm going to gift to my friend, and the other I'm going to build and keep myself. And then I'm going to try to convince Beck to get one as well, because he wants a macro keyboard. So yeah. How is everybody today? I just flew in, just arrived back at my home. I have a shepherd's pie cooling upstairs, and I'm gonna eat it later. Yeah, it should be a lot of fun. It's not like super complicated, I don't think. I don't think there's too many ways for me to really screw this up. So maybe I'll build my 2, and then I'll be able to tell you what to do. So should be all right. So today, I guess we'll start off by tearing apart my little stream announcement friend here. Oh, nice. Yeah, it should be really tasty. I was like, we probably need to try at least one. So we made sure we had like 1 extra so we could try it. They're super good. And like, she didn't put a lot of sugar in the frosting, which is ideal. I think just like a lot of cream cheese and like, very good vibe. Okay, I'm just gonna knock it down just a little bit. I was just helping out in a very COVID safe way of just helping out leading musicians set up his studio today, and got some of the audio stuff fixed. Man, yeah, that's a lot of work getting a studio up and running. but I think it's gonna work out all right. So we'll see. I'm gonna have to catch the VOD from tonight's stream, but I think I need to turn the music down in my ears because I'm too distracted by it. I think I just play with that a little bit. We're not really the best at attention span here in this department. Yeah, that's better for me. Cool. Yeah, he's live right now. Yeah, I don't know how it's gonna go, but he's got Stream Deck. He's got multiple cameras. He's got, oh man, it's great. So yeah. All right, so we're doing Project 5 tonight. And that is the last project from the Sparkfun Inventors Kit. And my friend who recommended that I just bite the bullet and get the Inventors Kit was totally right. I'm like absolutely hooked on this stuff. So I have this, like I mentioned, the PCBs for the keyboards on the way, and then I also have another kit on the way, and that's going to be like another Inventors Kit type thing. I'm probably just going to cherry pick out projects from that instead of doing it. It's not exactly clear whether they even truly exist or could be shown to. There's like weird audio in or speaking in this chill tune. I'm going to skip it. I'm going to cherry pick it instead of going through and through like I did this one. But there's some like RFID encoders and some other cool stuff. Actual servo motors instead of, I think these are just geared DC motors. I don't know if they're true servos. So we'll find where we're at. Yeah. All right, Project 5. Sick. And prior to starting Project 5, we're gonna take Project Stream Alert apart. So I'm just gonna plug this in for y'all so you can see it quick one more time. Yeah, this is a really fun project to work on. Zenhaver helped me code it, gave me some good tips on that. And yeah, this is kind of smashing a couple different projects together from the Inventors Kit. If you are thinking about getting into Arduino, Inventors Kit is awesome. It's a really, really good kit. And I learned a lot. Significantly more because I had Zenhaver in my ear telling me how things actually work, but it still, on its own, did a very nice job. So I'm just gonna start pulling stuff apart because I'm gonna need all these jumper cables. Now I made sure to unplug it and remove the power prior to doing any changing of my breadboard. Look at all those jumper cables. Right. I am digging this music. So I'm thinking, Vigor, at some point it'd be really fun to have you on as a guest as well. We could talk about more like coding-y, math type stuff. It would be kind of neat. It's pretty rad. You're pretty good at that stuff. Have like a truly dedicated math chat, but as an interview. For you to be very wrong. I mean, you have certain things you do quite a bit of with programming, right? It's not the same stuff that Zen does, but it still is programming. Potentiometer. Put that in there. Okay. LED panel. LCD panel, sorry. That is really tough to get in and out of that breadboard. It makes me nervous. I built a Raspberry Pi network accessible storage device, I think last weekend, and that went really well. Still running strong, still working very well. I'm excited about it. So that's another fun project. I think if anyone is wanting to do that, it's not like the fastest or anything, but it's a good project just to learn stuff on, get my feet wet in Linux a little bit more. Okay, project 5. So, project 5, that floor is kind of shaky, huh? Ah, robots, one of the most iconic and exciting electronics applications. In this project, you will learn all about DC motors and motor drivers by building your very own robot. You'll first learn motor control basics, then you'll control a tethered robot by sending it commands over serial. Last, you will unleash your robot by removing the tether, and making it autonomous. By adding a distance sensor, the robot can learn how to avoid obstacles. That is blurry as all get out, probably from my hat. All out of focus. The next thing I need to build is a thing to focus my camera out there because I can't actually get to it super easily. I have to do this, and this is a drag. Everyone sees my midriff. No one wants to see that. Alright. Some new components introduced by this project. The TB6612FNG motor driver, a switch DC gear motor, a wheel. New concepts introduced is input voltage, integrated circuits, H-bridge motor driver, ASCII characters, converting strings, autonomous vehicles. I will learn how to control a motor. Piece of flannel, you're right. How to control a motor using a motor driver, how to send serial commands and create a remote-controlled robot, and how to build a robot that uses sensors to react to its environment. So that's what we're going to learn tonight, I think. I think we have plenty of time. We can get through it. And Zen's not here for me to, badger about really specific things in electrical engineering, so it should go a little bit faster today. So, oh my gosh, need that piece of flannel. I don't know why it's not focusing. It's probably just me not knowing how to use my camera too well. But, goodness. Excellent. If you want to join on a call, man, just gotta let me know. We'll do it. Although I know you're just streaming for a while, so that can be a bit of a chore. Okay, so switches. Switches are components that control openness or closedness of an electronic circuit. Just like momentary buttons used in earlier circuits, this type of switch can only exist in one of two states, open or closed. However, a switch is different in that it will stay in the position it was last in until switched again. Yeah, right. I'm surprised that switches aren't the first thing that we do. Switches are very much pretty basic, right? Yeah. So surprised they didn't cover that earlier, but that's cool. The motors. In your inventor's kit, you have two main parts: a small DC motor that spins quickly and a plastic gearbox that gears down the output from the hobby motor so that it is slower but stronger, allowing it to move your robot. The motors have a clever design allowing you to attach things that you want to spin fast, like a small fan or flag, to the hobby motor, and things that you want to be strong, like a wheel, to the plastic axle sticking out the side of the motor. The included wheels just so happen to fit the plastic axles. Nice. That's fair. I've done such a small amount of plumbing. Oh man, you've done way more plumbing than I have. Better to learn how to attach an elbow or street to a few pipes before you get into the valves and diverters. Yeah, that's fair. I just I've put a bunch of switches and stuff already, on my truck projects, and like those kinds of things. It just seems like a switch is such an early component that you learn about, but maybe not. It's less important probably because it's probably just less that it's less important to learn about, maybe, I guess, because it's simpler. I don't know. The TB6612FNG motor driver. If you just switch the direction of the current through a motor by swapping a positive and negative leads, the motor will spin the opposite direction. Motor controllers contain a set of switches called an H-bridge that let you easily control the direction of one or more motors. The TB6612FNG motor driver takes commands for each motor over 3 wires, 2 wires to control direction, and 1 controls speed, and then uses these signals to control the current through 2 wires attached to your motor. Okay. So new concepts. Voltage in, VIN. I've been curious about this acronym. This circuit utilizes the VIN pin found with the other breadboard power pins. The VIN pin outputs a voltage that varies based on whatever voltage the breadboard is powered with. If the breadboard is powered through a USB port, then the voltage on the VIN, let's see, here, then the voltage on the VIN will be about 4.6 to 5 volts. However, if you power the breadboard through the barrel jack, highlighted in the picture, the VIN pin will reflect that voltage. For example, if you were to power the barrel jack with 9 volts, the voltage out the VIN would also be 9 volts. Notice that the voltage range listed on the breadboard near the barrel jack is 7 to 15 volts. This means that we recommend the input voltage should always be at or above 7 volts, or should be at or below 15 volts. Never exceed that range. Integrated circuits, ICSs, and breakout boards. An integrated circuit is a collection of electronic components, resistors, transistors, capacitors, etc., all stuffed into a tiny chip and connected together to achieve a common goal. They come in all sorts of flavors, shapes, and sizes. The chip that powers the breadboard, the ATmega328, is an IC. The chip in the motor driver, the TB6612FNG, is another IC. Integrated circuits are often too small to work with by hand. To make working with ICs easier and to make them breadboard compatible, they are often added to the breakout board, which is printed circuit board that connects the IC's tiny legs to larger ones that fit on a breadboard. The motor driver board in your kit is an example of a breakout board. And this is some of the stuff that we learned from Zen a couple weeks back. Once you've finished with the project, removing the motor driver from the breadboard can be difficult due to the numerous legs. To make this easier, use the included screwdriver as a lever to gently pry it out. Be careful not to bend the legs as you remove it. The motors are polarized. However, motors are unique in that they will still work when the 2 connections are reversed. They will just spin in the opposite direction when hooked up backward. To keep things simple, always think of the red wire as positive and the black wire as negative. Yeah. Cool. Meet your motor controller. The TB6612FNG motor driver may look complicated, but it's easy to use. 3 pins on the right, PWMA, so pulse width modulation and analog? I don't know what A stands for. A12 and A11 control the 2 pins on the left, A1 and AO2. The same is true for channel B. Motors require more current, which is why VIN voltage is needed. Most ICs have polarity and usually have a polarity marking in one of the corners. The motor driver is no exception. Be sure to insert the motor driver as indicated in the circuit diagrams. The motor driver pins are explained in the table on the next page. So here is our table. All right. So here we go. We got our VM, VCC, ground, A1, A2, B2, B1, ground. Okay. So let's just look at these here. So VCC is logic voltage. Voltage to power the chip and talk to the microcontroller. So this is the 2.7 volts to 5.5 volts. VM is the motor voltage. This is where we provide power from the whatever this is here. The let's say that the VIN pin must go there. Let's go to this VM one. There's our ground. This is the pulse width modulation input that controls the speed. Oh, it's PWMA, PWMB. I was thinking the A stood for something else. It was just to denote that it's A or B. Because there's two potential motors that this drives. Okay, that makes more sense. I was confused by that acronym, but they threw an extra thing in there for me. So, okay, so here we have the circuit diagram. So I think what I'm going to do is, let's get this in here first. Let's find it. Here's our motor driver. Out. Not replace the blade in this thing in like a couple of weeks and it is dull. No bueno. Okay. So let's get this in place. Let's center that. Oh god, it can't be centered. Dang it. Why would they do this to me? It's like Tim Beep's aquarium all over again. So I need to have it slightly off center apparently. It's okay, we'll be fine. Press this in here. Boy, that's kind of hard to press in. Try and rock it back and forth a little bit. There we go, that's the ticket. Boy, that hurts the hands. Goodness. Okay, I'm gonna make sure that my microscope is plugged in because, like, why even have a microscope if you don't plug it in? Better do that. Okay, find the cable. There it is. Let's get a good look at this motor driver. All right. Oh, I goofed it. Let's see if it likes me. Gosh, this thing is just picky. Makes me upset. Okay. Microscope working? Microscope not working. Shoot. Wow, what do you do? Okay. So we've got our motor driver in place. Now let's hook it up to all the things. So let's get some jumper cables out. This thing is just not cooperating tonight. I think I might actually be one of the things I do soon is make a little thing to press that button for me. I probably need to set it to like continuous autofocus or something. That's probably all I need to do, actually. But, whatever. So, VIN is here. Let's see if this is working yet. No. So, set that to VIN. And then this goes up to the VIN. This is weird. I definitely would have asked Zen about why they did it this way. So if we look at the this, the VIN power goes up and goes directly to this this here. Like, why are we using both sides of this rail if these are just going to connect to each other, right? That doesn't make much sense. Okay, so that connects to, it's 4 down, standby? So that goes down to the standby pin, the other positive. Maybe. I mean, I'm gonna hook it up exactly how they have it, but I would picture. It seems like it would be. I mean, maybe. Like it's like, so it's connecting the 5 volts here, like the regular power, to this rail, and then it's going up to the top of this rail, which goes to that 4th pin, the standby pin, and then it goes down and crosses here over to the other railing, and then up, and then this one is hooked up to the, this is the VCC, this is what actually controls the device. So, I don't know. Like, and then the VIM power, which is the higher amount of power, goes down through here. I'm digging this song though. I like it. Yeah, that's probably true. Just like not get it too far over there. Well, that's cool. We can still hook this up how they want here. So we're gonna put this one into the VIM goes into the top pin right along there. We've got that one in place. Let's get all of our power in place because that's probably the sketchiest part of this whole deal. So I'm gonna get my 5 volt. 5 volt is now plugged in up into, I'm going to put this in my 5 volt rail up top because that is easier for me to think about. Next we have 5 volts connecting to each other across the bottom of the rails. Get in there. Running out of red wires. Do we have enough today? I don't know if we do. So VCC goes to positive rail. And then the standby pin. Yep, standby. Also goes to positive. Kind of anywhere. Alright, here's all of our hot wires. Those are hooked up. We don't have it hooked up to the motors yet. I'm going to do that a little bit later. And those have their own leads. So let's get our ground wires in. So our grounds connect to each other, just like our positives do. Close in place. I'm going to hook up my main ground here, just to the ground area. Plug that in the rail, top. Then I need to connect it to, look like the ground over here needs to actually get connected. Okay, so here we have all of our positives and negatives hooked up. I'm actually I'm going to zoom in a little bit here. Physical zooming. Oh, Guess that's zoomed in all the way. Right. We are learning about motor controllers. Hey there, Zenhaver. Yeah, learning about motor controllers. So I just hooked up all of the positive and the grounds for this motor controller board here. Motor driver board. So I've got to hook up all of the digital outputs. Oh yeah, right. Okay, so this diagram.
But it's not a thing about making it accurate.
I don't really like the talking in here because it's confusing. So in this circuit, it does something like a little strange with the positives. So it connects the positives directly to this rail here. So this is the 5 volt. And then one pin goes to standby here. And then it bridges across and uses this all the way up to plug into the VCC pin on this controller board. The VIN power goes all the way up and doesn't even touch the left-hand rail. It just connects directly to this pin. And so my question is like, why even use both rails for this? Why wouldn't you just reserve the other rail for the other voltage and keep all of your 5 volt stuff, all of your VCC stuff on this side, and then reserve this for your VIN? Or is that just an organizational thing, like it's easier to get it to jump across with this bottom wire? It just seems a little strange. Like, why would they choose to do that? Oh, okay. So I thought that was the point of having different rails, is to like have different voltages on them, right? Because they don't connect with each other? Or is it better practice to just have that be a separate power thing? Really? All of the rails? Okay. That's fair. Okay. That is a good practice then. I think this is the danger, right, of learning stuff on YouTube, is that a random YouTuber might not do it that way. They might be like, yeah, and we're gonna put, 12 volts on this rail for this reason and these reasons, and then, because I've seen this happen, and then the 5 volt VCC stuff on the other. Thirsty. Okay. Cool. Right, nothing's stopping you, but it's maybe not a good convention. I appreciate that insight, Zenhaver, as always. I so appreciate your insight on this stuff, because it's really hard to sift through the nonsense. Beware. Sick. Okay, I'm gonna keep hooking this sucker up. So we're gonna start to hook up our digital pins, the digicals. I'm gonna try and stick with their coloring as best as I can, but there's not that many colors of wire available. So we're gonna do this Plumba PWMB, pulse width modulation B. That's got to go to a pin with a tilde on it. So we're going to pin 10. Yep, pin 10. Okay, so that's the one right there. It's the second up from the bottom. Next, we're using a white cable, and this is going to go to the, what does that say? Bin 2. This is the bin 2 pin. I really learn a lot about bins. What is that? BIN 2? One of 2 inputs that determine direction. Okay. I don't know much about bins. Maybe I should know more. parallel here. So is going to go to the bin 1 pin. And this in turn goes to non-pulse width modulated pin number 8. Red is already connected there. Got a blue pin. Or blue wire. This goes to AIN1, which is input, so one of the two inputs that show the direction. Okay. I'm not sure why there are two of those, actually. BN. Oh, okay. Not bin. Okay, that helps. And that's I've already been confused once by these instructions, thinking that the A or B actually was a word. Whoopsies. That's easy to do. Pin 13. Pin 13 then goes to the AN1. Yeah, I think that's what that means. Good clarifications on that. Totally missed that one. This one goes to AN2. Goes to pin 12. And then finally, we have the PWM, so pulse width modulation A. Yeah, this is good too. I like this. Good tunes tonight. Pretzel app has a new version that it alerted me to today. And so we got a new version of the app. It's working really well. I'm liking most of these songs. Not all the ones with talking in it, though. I don't really care for those too much. Oh, that's easy to miss. Look at this. I totally didn't see this whole part of this. This whole part with this switch. It's really easy to miss that. Gotta find my switch. Yeah, we're totally missing the switch from that breadboard. And this is gonna go. How did I miss that? Yeah, man, everything is on Switch now. I had to think as to your joke. I missed it again. Yeah, I've definitely been. Anytime I talk about Switches, and I've been able to make more of these jokes. I just got a new Switch myself. It's not as portable, but still apparently works really well. It's I don't know. It plays games, I guess. We'll have to see. Not sure. Oh boy. Dude, you got scammed. I think that Switch is worth more than a Nintendo Switch, actually. We'll have to see. It's a fancy Switch. Excited to get that, put that to use. So I'm not seeing any indication of this being polarized. They didn't really introduce much of this. Yeah, and then suddenly Wi-Fi happened. Yeah, network switches were pretty rad back in the day. Remember, multiple people would bring them to LAN parties because you never knew. One might die, and then you would all be pissed and have to go home and not hang out with your friends because the switch was broken. Yeah, Little Neck Gear 4 port. Yep, love that thing. I'm probably gonna get one of those for one of my future projects here, where I'm gonna be working on that, bug out computer thing. Yeah. Oh, Oh, good times were had. That's good. I was just thinking the other day about Unreal Tournament. And like, man, remember when we had, I think we had like a full 8 people or 10 people or something, or 12, some massive number at your house one time, all playing Unreal Tournament. And that was like, oh, good memories there. That was wild. Yeah. You had to have a really sturdy kitchen tables back in the day. Because you'd have like 6 CRT monitors on it. That's a lot of weight. That could have been tragic. So I'm wiring the center pin of my switch. I'm just going to put this a little higher in my diagram here. Center pin of my switch goes to ground. Cool. And then the bottom pin here goes to pin 7.
Yo.
Yeah, it sure did. It really did give out. That was I can pull up that picture if you want. That's one of my favorite pictures because we were all half drunk trying to salvage that. Actually, fun fact: the table legs for this table, this one right here, this table you see, I actually repurposed the leftover table legs from that table for this streaming table. So I like rebuilt it with this tabletop. So there's the fun fact of the day. Okay. So I think we've got everything configured. It lives. It does. It lives quite well. Oh, we need to hook up the motor yet. The star of the show. Alright, here's our motor. Take a close look at this thing. So it is a Dagu robot mini DC gearbox, 48-1. That's cool. Neat. So we're hooking this up to the ground and the A out 1. Actually, A out 1 and A out 2, not the ground. Because, right, they're going to switch polarities to go forward and backwards, that's right. God damn it. I unplugged something as I stood up, but I don't know what it was. Wrong place. You're good. You're good. Maybe not. Oh, no, I did. There it is. Okay. Okay, so put my spare wires away. Lots of extra stuff. And let's get into the Arduino editor. Arduino IDE. Open up circuit 5A, motor basics. Let's upload this thing. Oh god, it's like going because I'm already using these pins. That's no good. There we go. Whoops. Okay. So, let's see what this does. Okay, pin variables. The motor will be controlled by the motor A pins and the motor driver. Let me take a drink of water, excuse me. Better. Okay. Setting a constant of an integer on AIN1 is 13, pin 13. Constant int AIN2 is pin 12. Constant int PWM, also with modulation A, is 11. Switch pin is 7. Some variables. Excuse me, setting motor speed to 0. Initially, that's good. In setup, we're doing pin mode. Switch pin is an input pull-up. So, looks like not just momentary buttons, but with regular switches, not just momentary switches, but regular switches, you need to also call that it is a pull-up. Good to know. Let's see, set the motor control pins as outputs. So saying the AN1, AN2, and PWMA are all outputs. Connecting to serial, that's normal. Okay, serial print. Enter motor speeds 0 to 255. Okay, if serial is available, can I put stuff in the serial? Is that? What? You can send stuff to serial? I didn't know that. That's great. Sweet. I'm setting motor speed, so if serial is available. Nice. That's great. I wonder what I can. And I'm sure you can, like. Is that where you would pull additional information to, like, input into serial or something? Is it a good connection point for other bits of data to control speed, like writing something to serial and then reading from serial? Or not? I guess you just skip the whole serial portion and just write serial to where it needs to go. I don't know. Oh, man, these tunes are on point. I'm cold. Okay. So. So Zenhaver says, could be. I would probably choose a different interface for communication between things. That's fair. One thing I did want to call out to alphabets. I don't remember alphabets. You could definitely write up stuff in your serial that way. I can't tell if you're making a joke or if this is actually a reference that I've just forgotten because of my soft mind. Pull up? Pull up, you say? Alright, so serial print motor speed, okay. Print speed motor is set to run at. Cool. Later, Zenhaver. I did want to shout out and say thank you for your 3D printing stuff. Digging those anti-fog glasses things. Those are wild. Work really, really well. Thank you so much. Alright, so if digital read... too many puns. Yep. Punes. Digital read is 7. Set it. So if digital read pin 7 is set to low, so switch is on. Spin motor. If it's off by reading high, turn off the motor. Okay, straightforward enough. Okay. Function for driving the motor. If motor speed is greater than 0, right to AN1 high and AN2 to low. If motor speed is less than 0, AN1 to low, AN2 to high. Else, set both of them to low. Okay, so this is, if it's going exactly 0, it's going to set both of them to low. They're not going to do anything. Basically setting both of those to ground, maybe? Or something, at least low. And then this is reversing the direction here. Analog right, pulse width modulation A. ABS, motor speed, I don't know what ABS means. Okay, now that the mode is set, drive it at the entered speed. Absolute value? Okay. Motor speed is here. Okay. So let's go to serial. Let's do 1. Turn the switch on. I think it's on. Oh. Oh, it just does it for a few seconds. Where's the amount of time it does that? I'm not saying like how long it's supposed to be at a certain speed. I only did it for like a little bit. Maybe it's just because we're like setting the speed with a serial monitor. Like every time it like does a loop, it just takes a while. So if we like put a delay down here. I forgot how to write that actually. That's probably not correct. I have to open up another sketch just to verify. You're not a sketch. Yeah, should be good. No, doesn't do it. I'm gonna write my delay in there. And that should make it run longer, right? Yeah. All right. Oh, no, not really. Yeah, with the switch off, it doesn't do anything. So switch on, it still only runs it for a little while. Yeah. So the switch is on right now. But like, I don't know why it's just turning off. After a little bit, I feel like it should just keep going, right? Drive forward. Also, like, for this motor speed, it says to set a value between 0 and 255. But not negative 255, right? Would that work as a... I'm gonna do it. Hey, that worked. So it's, yeah, so it's looking at, there's our switch. Serial connection. Here's the loop. If serial is available, and it's greater than 0 motor speed, serial print motor speed, printed motor speed. If digital read 7 is set to low, which is the switch, yeah, I don't know why it's getting pulled back to 0. I think it's just going through the loop and getting set back. That's probably just like this variable, right? So if we change that, no, because that should only happen once. Switch if statement. If digital read 7 is set to low, that's the pin, connect to 7. If it's set to low, spin motor at motor speed. Else, spin motor speed 0. Yeah. So here's the spin motor. Yeah, I don't get it. I wonder if it talked about it. Yeah, it says send 0 to stop the motor. So it's reading a 0 character or something. Like, once it's done, it's like... Let's see if there's a troubleshoot. There's usually some troubleshooting. No, it's not our problem. That's none of our problems here. I don't know. I'm not sure why it's doing this. Maybe. Because it wouldn't be this, right? It reads the values for the speed from the serial port. I'm gonna, I think I'm gonna reset this thing, and then I'm going to clear, and then I'm gonna try putting something in that doesn't have any zeros in it. Got it. Does the loop close? Yep, that one looks like it closes. If else, yep. That looks fine. This delay is doing nothing. Not sure. I kind of might just continue. I don't know. I think I might just... Sure, okay. Add another deal. Sure, yeah. Nope, it still is only on for the same amount of time before it turns off. Wired correctly. It shouldn't matter that much with how this is wired. The rest of it is important, but it's either going to work or not work at all, right? So let's remove the serial thing as an option. Yeah, which isn't good. Yeah, it's reading a 0 as if I put it in there, right? It's seeing the motor speed set to 0 for some reason. You know what I might actually try is I'm gonna replace this serial motor speed thing and just set the motor speed and do that, because then that removes the serial being the problem and seeing if anything else is causing the issue. I don't know if the switch is causing much issue, because that should just be on or off, I think. But we'll try that one next. So I'm gonna do... So let's do this. Let's have it print the motor speed. So we're going to do... I'm just going to set motor speed up here. Int motor speed 50. Oh, I'm not even showing my screen. I'm sorry. So motor speed 50 here, and then I commented out this if statement about the serial parsing. Going to upload. Oh, oh, whoopsies. All right, because this is a thing. That's supposed to close. Oh yeah, okay. Yeah. There we go. Try that. Okay, so it's not going to show me anything in serial, but the motor is spinning. I don't know if you can see here. So the motor is spinning at a constant speed. Yeah, so there's that. Let's see what was maybe causing it. So I'm going to turn this back on. Put all that back. It doesn't make any sense. Why would it be writing to that? Anyway, I'm gonna re-upload and try this again. Maybe I just need to try again. Yeah, I don't know how we're getting the 0 value in there. Right now, we're just getting... Where the hell did my serial marker go? So right now, all we're doing is we're just like punching in. Right, we're just punching the value in there. Oh, it's working perfectly now. So, what? So what you have to do is you have to comment out code and then uncomment out code, and now it's fine. Ooh, it just turned off. That doesn't make any sense as why. That's right, we got another mystery 0. What? And it's not inputting anything, so. Oh, there we go. Now it's moving. There's our 50. It's like really slowly moving. Some kind of thing I can put on here so you can see it. Is it going to set back to 0? Is the delay still present in the spin motor function? It is. That's probably what's doing it. Let me remove this. I'll just kind of do it. Yeah, then it only runs for a little bit before it writes back to 0. I don't get it. Why is it doing this? So weird. Well, something's weird with the serial connection. Do you think I have the wrong baud rate? Could that be what's happening? Oh, try this, says Vikuger. What's he gonna say? Leave the serial function on. But init the variable, so default's 50. Hey, that's a thing. Yeah, and then that'll tell us if it's getting overwritten with a 0 by something, or if it's picking back up on that. Good thinking, Vec. So it's running at 50 right now. I just increased it to 150. And yeah, something is overwriting back to 0. It did not default back to 50. Per the logic, it will only enter motor speed 0 if it has detected a 0 on the serial connection. Yeah, so I don't know. That was a good test V. Kruger. That was a really good idea, because now we know that there's something weird overwriting on the serial connection. I don't know enough about how serial connections work. Maybe Zenhaver next week we can go through this and we'll jump back to why this was happening. Maybe? I don't know. Hear me and try adding a serial flush to the end of the if statement, checking for serial available. Happy to. Okay. To the end of the if statement, checking for serial available. Down here. Okay, let's try it. Okay, so we're running at 50 right now. go to serial monitor. I'm gonna type in 255. Same thing happened. So it went 255 for just a second and then went back to 0. Oh god, everything's broken. Oh god. I mean, what is this telling us? Is this something that could be wrong with the breadboard? Could this be software? What would be a good way to troubleshoot this? Just like do a real basic program with some serial input and see if it resets it or something? Something with my PC. Oh, interesting. Would going through a USB hub be part of the problem? Potentially. What an interesting scenario. I think. Let's see here. Well, I think I might move on. I don't know how much we're going to be controlling this from serial in the next thing. I'm just going to check and see if the next things have serial in them. I might move on if they do, just because I want to try and get this done tonight if possible. But so yep, this does a serial command as well. So we're going to continue to have this problem. Huh. Yeah, it's real strange. I'm going to troubleshoot USB ports. So this will require us to change the COM port. So we're going to a much more direct connection to the computer. I'm using a powered USB hub that seems to work quite well with all kinds of stuff. Like I can run cameras and stuff off of it and it's fine. So we'll see. I'm going to probably have to switch this back, but I switched, yeah. So error occurred with the sketch. COM4 is not working, so we need to switch our, go to tools and go to port, go to COM1, and then try to upload. Okay. So we have a different COM port. So I'm running at 50 right now. Oh, interesting. So I'm getting port busy now. Yeah. Can you check your serial communication settings in Arduino IDE? So, file preferences. Is there anything there? So COM1 doesn't seem to be working. Let's try COM5. You pick the baud rate in the right here. In the sketch you pick it. Oh, where do I pick the baud rate? I don't know. I don't think I ever did. There's a thing that says fix encoding and reload. Maybe that's a thing to do. Nothing on baud rate here. I don't know, gang. This one's a head scratcher. I'm also not really getting an upload. I think I'm gonna reboot the IDE actually. So let's reboot that and see if there's just like something funky going on. Oop, that was music, not Arduino IDE. Dang it anyhow. The new Pretzel app really annoyed Windows. Windows did not like it. Go back to that station. Sure, yeah, I'll do that. So Zenhaver recommends checking the serial monitor to see if my settings are there. So I'm gonna open recent, motor basics, tools, serial monitor. Yeah, it is there, yeah. Looks like I'm still potentially getting an error on upload here since I changed ports. It's not really doing it. Yeah, you can set the baud rate down here. You can set to auto scroll, show timestamp, new line, or change the baud rate. No line ending. Okay. I might switch this back to the other serial port though, because it's not working right now. Okay. All right. I gotta get my port stuff sorted back out. I am not seeing my port 4 back. Gonna get stuck on upload here. Yep, just getting a cryptic message now. Oh, there's COM4. This should work. No, that actually didn't work. So compile's fine, let's send it over. There we go. Okay, now we're back in action. Back to our serial monitor. So we have no line ending added. Let's try 255. Hit enter. Hey, that did it. For sure. Yeah, we're running. We're running at 2:55. All right, Zenhaver. What did we do? Exactly. What did that? Oh, what? What? So, it was attaching a new line to the end of all your serial communications. Oh. Okay. Software is parsing the new line character as a 0. That makes sense. Sweet. I wonder if it tells me in here to like change it from new line, and I just didn't even read it because honestly we've been on autopilot for a lot of these when it gets to the code. Let's actually read the instructions here. So I'm gonna turn this off because it's loud. No, it doesn't say anything about the new line. Neat. Well, good job, team. Thank you, Zenhaver, for explaining that and thinking of some good ways to troubleshoot. So, some of our steps were to check some of the different connections, turning on and off various pieces of code, and then messing around with the serial connection. So, that's definitely something I'll look into more with these next ones, just to make sure that we can actually do these next projects. Cool. That's always fun. I like troubleshooting stuff. Or like getting to the other side of troubleshooting stuff. Alright. You know what this means. Circuit 5B time. Okay. Circuit 5B. In this circuit, you'll control 2 motors and build your own remote-controlled moving robot. You will also learn how to read information from a serial command so that you can use serial monitor to tell the robot in which direction to move and how far to move. Take this thing aside. Some new concepts. ASCII characters. ASCII is a standard for character encoding formalized in 1960 that assigns numbers to characters. When typing on a computer keyboard, each character you type has a number associated with it. This is what allows computers to know whether you're typing a lowercase a, an uppercase a, or random characters such as an ampersand. In this experiment, you will be sending characters to the serial monitor to move your remote-controlled robot. When you send a character, the microcontroller is interpreting that as a specific number. ASCII tables available online make it easier to know which character is represented by which number. Converting strings to integers. String variables hold words like dog or Robert Smith that are made up of multiple characters. Arduino has a set of special built-in methods for string variables that you can call by putting a period after a variable name. As follows: string variable name, period, toInt, parenthesis, semicolon. The toInt, parentheses, method converts the string to a number, and there are dozens of other methods you can do things. You can do things like tell you the length of a word, or change all the characters. Oh no! Or change all the characters in the string to uppercase or lowercase. Some assembly. Before you build the circuit, you'll need to make a few modifications to the breadboard baseplate to make it more robot-like. Things I'm not gonna do. Sorry. I don't really want to add that stuff because I'm planning on using this board a lot, I guess. Maybe I should, I don't know. I don't really want to adhere things to other things, really. If I can help it, because then my breadboard's going to be all off kilter. So it says to cut 2 short pieces of dual lock tape to the very corners of the base plates, side and under the breadboard. We are a little afraid of commitment. Because, like, you know, I'm probably not going to save this robot for a while. Probably not going to happen. Maybe someone else wants to build it from the inventor's kit. I don't know. Maybe. Yeah, totally just afraid of the commitment of it. So, looks like adding some motors to things. Maybe I should. I don't know. What do you guys think? Should I just attach the stuff? I guess it is just Velcro, but maybe I want to use these motors some other way. I don't know. Dual lock or fancy Velcro. Oh, this stuff is super cool. I need lots of this. This is great. Just buy a second kit for parts. I did buy a second kit. Not this particular kit, but I bought a whole nother kit recently, and I'm totally just using it for parts. I'm psyched about it. It's gonna be really cool. So we'll see how that works out. Let's see. I should probably just Velcro it on. That's probably what I should do. Alright. So we do want to do this by the book, I guess. Somewhat. Share that motor. This is just the same circuit, but I just attached the second motor. Side did it go on? I'm gonna read ahead. We're gonna look ahead and see how much we got here left. What other things do we do in this whole kit? Because this circuit is just adding another motor. That's all it really is. And this one is doing some of the avoidance stuff. I think we should just let's get it done. We're almost finished. We're nearly there. So cut and attach 2 pieces of dual lock. One piece. Okay, there's 2 pieces. I'm going to unplug this. And it says to install it. The very corners of the base plate on the side located under the breadboard. Okay, I'm gonna remove the motor for a minute because it's kind of dangly. The breadboard, not the circuit. So it's this side. What's this week like? What's this week look like for everybody? Vec, I think you have tomorrow off, right? Wise man. You're such a wise man with the days off. Wiseman. So very talented. Monday and Tuesday off. Damn. Brilliant. and December 24th, January 1 off. Very good choices, my friend. Zenhaver has different news to showcase, though, that this week looks like complete nonsense. That's too bad. Can be finishing up her semester. That'll feel good. Some totally even pieces of tape. Okay, what's next? Got 2 more strips. Remove the adhesive backing and attach them to 2 motors. Be sure that your motors are mirror images of each other when you attach the dual lock. What the hell does that mean? So I think it just means like this. I don't have any scissors down here. It's something I should remedy, most likely. Oh no, that's not the right size. I have to like shave some of this extra off here. Utility knife is perfect for that. This is so tedious. This is the tedious part here. There we go. Dual lock. This stuff is cool as hell. Probably gonna get some for some other projects. Just fancy Velcro. Okay. So now it says to attach it. So oh, there it goes. All right, good thing it is durable. So let's set this up here. Whoopsie daisies. Not lined up super good, but that's okay. Okay. Wheels. It would be kind of fun to make an RC car. Like, there's some pretty cool RC car kits out there. My friend Joe got into RC cars not too long ago, and he says they're a blast, except that he ran his into a wall going like 70 miles an hour, and it just basically broke every single part. So there's that. That's a thing. Potential issue. Oops. Let's try that again. Get on there, dang it. There we go. Okay. Binder clip. Does the thing. So it says I'm going to use the other piece there. Alright. Binder clip here just as an extra caster. Okay. And I need to put a piece of dual lock on the very bottom. I didn't do that in that other circuit, and it looks like we'll need that to hold the battery pack, so. All right. Here's the battery pack. Yeah, okay, I'm glad I'm doing this. This is kind of cool. Wasn't so sure at first. So let's go like this. Been making a lot of shepherd's pies with this, all these Thanksgiving leftovers that I made. I made a big batch of chicken dumpling soup last week, and that's been a really excellent base for the shepherd's pie and all the mashed potatoes and stuff that I made as well. So pretty psyched. All right, cool. So now that we've done that, all that stuff, we're going to go ahead and hook up the second motor. Okay, so motor 1, also these aren't marked, so I'm going to do this one's going to be 1. This diagram's kind of hard to look at, but we go to A1 and A2 and B2, B1 and B2. So red here, this goes to A01, B01. This goes to A02, and I'm thinking the polarities are flipped. So 1 and 2 are different for the two different motors. So I'm thinking that's probably because they're mirrored, right? Like they're not facing the same way, so why would they have the same polarity? So if we had 2 more motors and wheels, then we would do something on the other side. So Zen, my big question for this week, which we can talk about next week, is when do you decide if your project is too big for an Arduino, for a single Arduino? What tells you that it's too big? How do you make that choice? When do you decide to have multiple Arduinos controlled by like a Raspberry Pi or some other kind of scenario like that? So we'll have to talk about that next time. Yeah, I know. But there's like a lot of stuff, and I've noticed there's a lot of projects out there that are like, yeah, I'm using like 6 of these chips and like blah blah blah. And it seems like if you're really clever, you can get more stuff done with a single card, with a single chip. You know, a single Arduino is capable of doing multiple things if you're clever about stuff. But if you're not clever about stuff, you could just do like one task Terry's. I don't know. So I don't know. We can save that if you want. It'd be good to talk through that in the future. So I'm gonna make sure my switch is turned off. And then I'm going to plug this in. The motors aren't just spinning. Oh, mine is on apparently. Oh, I set it to 50. Oops. Oh, there we go. That's off. Okay. At a high level, the most common limiter is probably the number of I/O pins, but it would be a fun, deeper conversation. All right, cool. I love fun, deep conversations. We're gonna open up the next sketch. 5B, remote control robot. Let's upload this thing. Okay, so here's our A group and our B group. PWMB and PWMA control the speed. Switch pin is 7. Constant, so drive time is set to 20 as a constant. Turn time is set to 8. Strain bot direction and bot distance. The direction that the robot will drive in changes which direction two motors will spin in. Okay. Distance travel in each direction. So setup, pin mode, switch pin, set to pull-up mode, that's cool. These are all set to outputs. Here's our serial line. So for serial print in, enter a direction followed by distance. Okay. F forward, B backward, R right turn, L left turn. For example, F50. These are nice instructions, I like these. Okay, so here's the on-off switch. Right. That's cool. Getting tired, folks. So here's the... Okay, so that's distance. So that's turning the distance into an integer. Okay, cool. Let's do F20. We gotta turn it on first. It like kind of did something, and it stopped. Okay, enter motor speed first. So motor speed is 200. Something's weird. I'm gonna clear my output here. I think I'm getting confused. Set. Okay, enter direction followed by, so example command F50. So let's try that again. F space 50. So they only kind of turned a little bit and not in the same direction. So did something else change the wiring? No. Those are all the same. This thing's wonky. So the distance represents Let's find it. That's just a delay. Drive motors long enough to enter the given distance. It doesn't say. So the reason why I'm saying like that it's weird is because like when I did, let's do F200. Space 200. The motors are spinning in opposite directions. Hey, thanks, lady musicians. Yeah, the motors are spinning in opposite directions, which doesn't make sense. Yeah, because it would just spin otherwise. I wonder if I need to swap polarity on something or if it's in the code. So that's one thing that's confusing about this is that when I was looking at this, like it's telling me to do, so A1 is positive, A2 is negative, but, oh, okay, it's actually swapped in here too. So B1 is positive and B2 is negative. Okay, so that does make sense. Yeah, so that all checks out. So, it's really got to figure out why my camera does this. Why my wheels are going backwards. Is there a troubleshooting pin for it? So right motor and left motor. Here's right motor. Could one of the motors be mounted upside down? They told me to do that. I mean, I could just swap the polarity on those pins, right? Like that would work. Yeah. And I could do it in software as well. I'm going to do it in hardware. Turn off power and swap these pins. Try that again. Okay. So maybe this will drive on here, maybe it won't. Serial monitor. So we're gonna do F space 20. Enter. Oh my. Serial issue at Java event dispatch thread. Hump events. Whoa, errors. Let's try uploading again, see what that does. Done uploading. Abort. Nothing happened. Yeah, there we go. Now they're moving in the same direction. It can't move its own weight though. it like is unable to actually move itself back and forth. So R 400. There you go. Now it's moving and grooving. B 30. Yeah, I think you're right. Cool. Hey, Project B, we're done. Good job. Okay, here's the next and final. So we're going to use our distance sensor. On this deal. Let's do it. I'm so excited. We're gonna finish. Yeah, that's the next thing. Oh, did they say that? They might have said that. Because why else would we have the VCC plugged in? Well, we're gonna do it for this one anyway. So, distance center. So these are going in at 18, 19, 20. I'm all out of red pins, red jumpers. I have to settle with blue, yellow, and white. I just plugged something into the breadboard without powering it down. That's a bummer. Dang it, Grant. Hopefully I didn't wreck anything. So, alright, I'm using yellow as hot. Goes here. Into my rail. Doing green is green. Here's the second pin. And that's going to PWM digital input. And then actually we should use and then white goes to pin 5. Which is also a PWM pin. I don't know if we're using it though. And then finally, our ground. Which goes to the ground. Cool. That's it. Okay, I'm going to open up the sketch. And I'm going to file, open. Autonomous robot. Okay, can upload the sketch. This robot will drive around on its own and react to obstacles by backing up and turning. This sketch was adapted from one of the activities in Sparkfun Guide to Arduino. So, upload this thing. So there's the left and right motors, distance variables. So triggered pin 6 and 5, that's accurate. Switch pin is at 7. So there's a float, that's the distance, so that's a decimal point. This is stored by the distance sensor, just like we did before. Backup and turn time as it tries to back up and turn. So, pin mode, echo pin. Where's echo pin? There we go. Echo pin is at 5. So, trig pin is 6. That's going to be sending out the sonar. Pin 5 is listening for it. It's those there. Here's a switch pin set as input pull up. Here's our fun little motor drivers. So detect the distance by reading the distance center. So distance equals get distance. So this prints the distance in place. Inches. Okay, those are all our motor drivers. And here's our echo distance stuff from our other project. So this senses the echo time. Calculate distance, so right trig pin to high, sends out the sonar, wait 10 seconds, maybe 10 microseconds there so that we know that it has happened, and then right on the trigger pin low. Cool. I'm kind of afraid to turn this on. I'm gonna plug in the barrel jack though. And let's see what this does. Kind of not so sure about putting this, just running this on my desk. Mostly because I don't think it has enough power to do anything. Thank you, Thank you, Mr. Zenhaver. I think I'm done. I think this is it. This is the whole Sparkfun Inventors Kit. Thank you so much, everybody. I'm hungry right now. I have not eaten dinner, so next week we're either going to be working on our keyboard project or the next kit that I have. So thank you so much. Hope you all have a wonderful evening, and I'll see you potentially on Tuesday for playing some The Long Dark, and then possibly Thursday for some other kind of long darky, crafty kind of thing, maybe knife sharpening, maybe boot projects. So have a great night. Thank you, V. Kruger, for rating. Much appreciated. Goodbye.